Okay, we're going to give this a try. We have here, this is um, a little setup we're going to use to talk about acceleration. What I have here is a little red cart that is on this track. Right now it's being held in place by this large black mass, but we see that the track is slanted down. We have a higher end here and a lower end here. So when I let go of the mass, I remove the mass, I should say, the cart will start to roll downhill. So first, let's just watch this without taking any data. Watch it and make some general observations about the cart. Right now, the cart is at rest. When I remove this for an instant, it is still at rest, but it starts to move. It starts to change its position. We'll watch that again. So later it's down there. Not only is it changing position, but something is happening to the speed. Here it has a fast speed. Here it has zero speed when I let it go. So right there we have enough evidence to notice that there is a change in velocity. The velocity gets faster and faster and faster and faster and faster as we move down the track. So what we'd like to do now is take some data to see how that velocity changes. So give me just a second. I'm going to move my camera here, see if we can get both of these things. Behind the cart is a little green box. You can see it just barely in the video. Right here is a little green box with a little green light on it. And what this is called an ultrasonic sensor. It's going to send sound waves over and over and over and over and over and listen for those sound waves reflecting off of something in front of it. Now, the thing that they're going to be reflecting off of is the cart itself. And the sensor and the computer software uses the time between those sound waves bouncing to the cart, back to the sensor, to the cart, back to the sensor, to the cart, back to the sensor, to determine the position of the cart. So we're going to track position here on this graph on the computer here. Let's see if I can get everything in frame. There we go. This is going to chart the position, how far away the cart is, that's the y-axis, every instant in time, that's the x-axis. And then here, the computer is also going to use those positions and those times to calculate velocity, the speed. It's going to say it's positive because it's away from the sensor. That's just the default setting. So we have the speed or the velocity in the positive direction. Excuse me, we have the velocity, the speed in the positive direction, and the time here on the x-axis. And what we're also going to spend a little bit of time looking at, and in your activity, you're going to look at the actual data points to calculate the acceleration based on the velocity calculations that are recorded here. So let's make sure that we can see as much as possible. I know it's always hard to record a laptop screen, but whoop, I'm moving the camera, pardon me. We're doing our best. I want you to see that we are taking simultaneous measurements of position as the cart comes towards us. And hopefully, it might have a big bang when it hits the end of the track here, but hopefully it won't be too rough. So I have to make sure I can get there in time. So I only have 5 seconds to do it. We're going to hit record, and then I'm going to remove that mask. Awesome. So right here, and I'm checking to see how it's showing up on the video. Gotta get my light. That's pretty good. That's pretty good. So here we have the position. It was flat, meaning it wasn't changing its position. The position was a constant location. And then right here, it starts to go farther and farther and farther and farther away. The position here is changing as time goes on. Here is where it hit that end. You heard that loud crash. We're not going to pay attention to that. And then the velocity data, let's zoom in on the velocity. Pardon me while I just make this a little easier to see. Again, that big spike at the end is not really something we need to worry about because that was the cart hitting the end. Oh, perfect. So again, we had a zero velocity, and I'm just trying to get a non-glare. I'll hold it still as soon as it's easy to see. That's pretty good. We had a zero velocity, and notice right when the position starts to change, we have a velocity. But our velocity is not constant. Our velocity is getting bigger and bigger and bigger and bigger and bigger. So what we're going to do is look at some of the data points. We see we have a whole bunch of data points. I'm going to export these into a more manageable table, get rid of all those times where nothing is happening and it's just flat. You see there's a bunch of 0, 0, 0, 0, zeros for velocity, 175, 175, 175, 175, 175 for position. I'm going to get rid of all that and just give us some of the data where things are changing so that we can practice calculating the acceleration of this cart given the velocities. We're going to use the formula for acceleration that you saw in a previous video, velocity final minus velocity initial over the change in time. So I wanted you to see the experiment that you're using the data from so you can kind of picture in your head what these numbers are representing. Remember, the cart was moving down the track. It was going faster and faster and faster. We see that here in the picture, faster, bigger and bigger and bigger speeds, right? And we're actually going to use some of the data to do our calculations. Great work.